प्यारे बच्चों, आज हम 9th क्लास का मैथ पढ़ेंगे। देखते कौन चैप्टर आता है? स्टैटिस्टिक्स। ठीक है, चैप्टर 14। इंट्रोडक्शन देखते हैं इसमें भाई हम क्यों पढ़े स्टैटिस्टिक्स। Every day we come across a lot of information in the form of facts, numerical figures, tables, graphs, etc. These are provided by newspapers, televisions, magazines, and other means of communication. These may relate to cricket, battings, or bowling averages, profits of a company, temperatures of stage, expenditures in various sectors of a 5-year plan, polling results, and so on. These facts or figures, which are numerical or otherwise collected with a definite purpose, are called data. ठीक है। Data is the plural form of the Latin word datum. Of course, the word data is not new for you. You have studied about data and data handling in earlier classes. Our world is becoming more and more information oriented. Every part of our lives utilizes data in one form or the other. So it becomes essential for us to know how to extract meaningful information from such data. These extraction of meaningful information is studied in a branch of mathematics. It's called statistics. The word statistics appears to have been derived from the Latin word status, meaning a political state. In its origin, statistics was simply the collection of data on different aspects of the life of people useful to the state. Over the period of time, however, its scope broadened and statistics began to concern itself not only with the collection and presentation of data but also with the interpretation and drawing of inferences from the data. Statistics deals with collection, organization, analysis and interpretation of data. कलेक्शन का मतलब इकट्ठा करना, डाटा को इकट्ठा करते हैं, ठीक है, फिर उसको क्रम से लगाते हैं, उसको विश्लेषण करते हैं कि किस तरह का क्या है, ठीक है। इंटरप्रिटेशन का भी यही है कि उसको हम समझाने का हो जाते हैं बाद में, ठीक है, व्याख्या करते हैं, उसकी व्याख्या करते हैं। The word statistics has different meanings in different contexts. Let us observe the following sentences. May I have the latest copy of Educational Statistics of India? I like to study statistics because it is used in day-to-day life. In the first sentence, statistics is used in a plural sense, meaning numerical data. These may include a number of educational institutions of India, literacy rates of various states, etc. In the second sentence, the word statistics is used as a singular noun, meaning the subject which deals with the collection, presentation, analysis of data as well as drawing of meaningful conclusions from the data. In this chapter, we shall briefly discuss all these aspects regarding data. Number 1 है 14.2 collection of data. Collection of data. Let us begin with an exercise on gathering data by performing the following activity. Divide the students of your class into 4 groups. Allot each group the work of collecting one of the following kinds of data. Number 1, height of 20 students of your class. Number 2, number of absentees in each day in your class for a month. Number 3, number of members in the families of your classmates. Number 4, heights of 15 plants in or around your school. Let us move to the results students have gathered. How did they collect their data in each group? Did they collect the information from each and every student, house, or person concerned for obtaining the information? Did they get the information from some source like available school records? The first case, when the information was collected by the investigator herself or himself with a definite objective or in her or his mind, the data obtained is called primary data. In the second case, when the information was gathered from a source which already had the information stored, the data obtained is called secondary data. Such data which has been collected by someone else in another context needs to be used with great care, ensuring that the source is reliable. By now, you must have understood how to collect data and distinguish between primary and secondary data. Give 5 examples. चलिए तो तुम कर लोगे. Presentation of data. As soon as the work related to collection of data is over, the investigator has to find out ways to present them in a form which is meaningful, easily understood, and gives its main features at a glance. Let us now recall the various ways of presenting the data through some examples. Example 1. Consider the marks obtained by 10 students in a mathematics test as given below. 55, 36, 95. 95 के बाद 73, 60, 42, 25, 78, 75, 62. And in this data there is no sequence. The data in this form is called raw data. By looking at in this form, can you find the highest and the lowest marks? Did it take you some time in search for maximum and minimum scores? Wouldn't it be less time consuming if these scores were arranged in ascending or descending order? Let us arrange the marks in ascending order as 25, 36, 42, 55, 60, 66, and so on, 95. Now we can clearly see that the lowest marks are 25 and highest marks are 95. The difference of the highest and the lowest values in the data is called the range of the data. This is important, the range of the data. So the range in this case is 95 minus 92, 25 is equal to 70. Presentation of data in ascending or descending order can be quite time consuming. particularly when the number of observations in an experiment is large, as in the case of the next example. Consider the marks obtained out of 100 marks by 30 students of class 9th of a school. You can read easily the 10, 20, 36, 92 and so on, 60, 88. Recall that the number of students who have obtained a certain number of marks is called the frequency of those marks. For instance, 4 students get 70 marks. So the frequency of 70 marks is 4. Frequency. To make the data more easily understandable, we write it in a table given as given below. 10 marks 10, the number of students, that is the frequency. 10, 1, 21, 36, 3 and so on. 64, 74, 72, 1 and 95, 1. Total 30. Table 14.1. This table is called an ungrouped frequency distribution table, or simply a frequency distribution table. Note that you can use also tally marks in preparing these tables, as in the next example. 100 plants each were planted in 100 schools during 1 month. So after 1 month, the number of plants that survived were recorded as 95, 67 and so on. 34, 36. To present such a large amount of data so that a reader can make sense of it easily, we condense it into groups like 20, 29, 30, 39 and 90, 99. Since our data is from 23 to 98, these groupings are called classes or class intervals. And their size is called the class size or class width, which is 10 in this case. In each of these classes, the least number is called the lower class limit and the greatest number is called the upper class limit. For example, in 2029, 20 is the lower class limit and 2099 is upper class limit. Also recall that using tally marks, the data above can be condensed in tabular form as follows. Number of plants survived, tally marks, number of schools, frequency. 2029, 3. You can really understand this. So next, presenting data in this form simplifies and condensing data and enables us to observe certain important features at a glance. This is called a grouped frequency distribution table. Here we can easily observe that 50% or more plants survived is 8 plus 18 plus 10 50%, yeah. From here 8 plus 18 plus 10 plus 23 plus 12 is equal to 71 schools. We observe that the classes in the table above are non-overlapping. Note that we could have made more classes of shorter size or fewer classes of larger size also. For instance, the intervals could have been 22, 26, 27, 31 and so on. So there is no hard and fast rule about this except that the classes should not overlap, right? Let us now consider the following frequency distribution table, which gives the weights of 38 students of a class. Uh, Weights in kilogram, number of students: 31 to 35, 9; 36 to 45, and so on. 71 to 75, 1. Total 38. Now, if we two new students of weights 35.5 kg and 40.5 kg are admitted in this class, then in each interval will it include them? We include them. We cannot add them in the ones ending with the 35 or 40, nor to the following ones. This is because there are gaps in between the upper and lower limits of the two consecutive classes. So we need to divide the intervals so that the upper and lower limits of the consecutive intervals are the same. For this, we find the difference between the upper limit of a class and the lower limit of succeeding class. We then add half of this difference to each of the upper limits and subtract the same from each of the lower limits. For example, consider the classes 31 to 35 and 36 to 40. Lower limit 36, upper limit 35. Difference 1. Have the difference 1 by 2, 0.5. Now, the new class interval formed from 31 35 is 31 minus 0.5 plus 35 plus 0.5, that is 30.5 to 35.5. Right. Similarly, the new class is formed for the class 3640 is subtract 0.5 from lower limit and add 0.5 to upper limit. 35 to 45. 35.5 to 40.5. Continuing in this the same manner, the continuous class is formed are 30.5 to 35.5, 75 to 75.5. Now, it is possible for us to include the weights of the new students in these classes, but another problem crops us because 35.5 appears in both the classes, in this class and also in this class. In which class do you think the way should be considered? If it is considered in both classes, it will be counted twice. By convention, we consider 30.5 in the class 35.5 to 40.5, not in this class. Similarly, 40.5 is considered in 30.5, 40.5 to 45.5, not in this class. So the new weights 35.5 kg and 40.5 kg would be included in the classes, this class and this class respectively. Now, with these assumptions, the new frequency distribution table will be as shown for below. This is nearly same. Hmm? Okay, thank you.